Hello, and welcome to PreCalc Lesson 20. Today we are going to be introduced to two very special friends who are going to help us along in our trigonometry journey, and those are the two special triangles. So, it is the 30, 60, 90 triangle and the 45, 45, 90 triangle. Now, why are these triangles important? That's a square root of 2. These triangles are important because in trigonometry, we often want to know the ratios involved here. In Algebra 1, we talked about sine, cosine, and tangent. Sine, if you remember, of an angle is opposite over hypotenuse. Cosine of an angle is adjacent over a hypotenuse. And tangent of an angle is opposite over adjacent. If we memorize these two triangles, which I highly encourage you do, then I can find sine, cosine, and tangent of 30, 60, and 45 quite easily. Let's do that now. So what would sine of 45 degrees be? Well, sine of 45 is going to be the opposite side, 1, divided by the hypotenuse, square root of 2. We don't like square roots in the denominator, so we'll write this as square root of 2 over 2. Similarly, because cosine of 45 will have the same result, right? Cosine of 45 is adjacent over hypotenuse. That also equals square root of 2 over 2. If I wanted to find tangent of 45, that would be opposite over adjacent, which is 1. All right, so you can use your reference triangles to find sine, cosine, and tangent. Let's go to the 30, 60, 90 triangle. I'll rewrite it here for your convenience and viewing pleasure. Just in case you're wondering, it's really easy to get these triangles. We use them because they have nice numbers, but suppose you're like, oh, I can't remember how to get the triangle. It's actually really easy. This one is a square chopped in half. Why? Because you want 45-degree angles, so if you take 90-degree angles, with all sides 1 and chop it in half, what do you get? You get triangles with 45 degrees, 45, and 90 with sides 1, 1, and if you do the Pythagorean theorem, you get that the hypotenuse is square root of 2. To find this triangle, we start with an equilateral triangle with all sides equaling, or all angles equaling 60 degrees. So if you take an equilateral triangle with all sides of length 2, all angles are 60 degrees. So if you're ever scrambling, 45, 45, 90 triangle, take a square, chop it in half, right? Half of 90 is 45. If you're ever struggling with the 30, 60, 90, take an equilateral, an equiangular triangle with side 2 and chop that in half. Why? It's got angle 60, but it also has now a 30-degree angle. And it has a right angle. Half of 2 is 1. We can do the Pythagorean theorem to figure out this is square root of 3. From there, we can find sine, cosine, and tangent of 30 and 60. So let's do that. Sine of 30. So 30 is here. The opposite side is 1. The hypotenuse is 2. So sine of 30 is 1/2. Cosine of 30. And I will have you memorize all of these. So at first, I'll allow you to use the triangles, but eventually you just need to know them. Cosine of 30, this is 30. Adjacent is square root of 3. Hypotenuse is 2. Tangent of 30. Here's 30. Opposite side is 1. Adjacent is square root of 3. We don't like to have square roots in the denominator, so it's square root of 3 over 3. let's do all the 60 ones now, and we are almost done. Sine of 60 is opposite over hypotenuse, so that's square root of 3 over 2. Cosine of 60 is adjacent over hypotenuse, or 1/2. And tangent of 60, square root of 3 over 1, or just the square root of 3. You'll notice that these guys swap for 30 and 60. That's because 30 and 60 are they're off by 90 degrees, and so that's important in triangles. Anyways, with all that said, that is problem set number 20.